Imagine standing on a silent planet far away from Earth, so far that even the light from our sun would take billions of years to reach you. The stars stretch endlessly across the dark sky, glowing like scattered diamonds. Suddenly, right in front of you, the air begins to twist. A swirling tunnel of blue and golden light appears, a hole that looks like it's cutting through reality itself. You slowly walk forward, feeling a strange pull, and before you can even take a breath, you're pulled inside. In the blink of an eye, you're no longer on that planet. You're somewhere else entirely. Maybe another galaxy, another time, maybe even another universe. What just happened? This is the mind-bending idea behind wormholes, mysterious shortcuts through space and time. For decades, scientists have wondered if such tunnels are possible. Could we travel from one corner of the universe to another in seconds? Could wormholes allow us to bend the rules of time itself? In this video, we're going to explore everything. What wormholes are, how they might work, whether we can build them, and why they've become one of the most fascinating ideas in science. A wormhole, also known as an Einstein-Rosen bridge, is a theoretical passage through the fabric of space-time that connects two distant points. To understand this better, imagine space as a flat sheet of paper. If you put a dot at one end for Earth and another dot at the other end for a star thousands of light years away, normally light would have to travel across the entire sheet to reach the star. But if you fold the paper so the two dots touch and punch a hole through them, suddenly you can move between the 2 points almost instantly. That hole is what we call a wormhole. This concept comes from general relativity, developed by Albert Einstein. Along with Nathan Rosen, he proposed in 1935 that two black holes could theoretically be connected, forming a bridge in space-time. This bridge, if stable, could allow something to enter from one side and exit from another, no matter how far apart the two entrances are in space or even in time. To understand wormholes, we have to understand how space and time work. They aren't separate things. They are woven together into a single four-dimensional fabric called space-time. Massive objects like stars and black holes bend this fabric. This bending is what creates gravity. A wormhole is like folding that fabric so much that two distant points come close together. Think of it like a subway system through the universe. Instead of taking the long, curved road on the surface, you use an underground tunnel to get to the other side quickly. According to Einstein's equations, these tunnels could theoretically exist. But here's the tricky part. Just because the math works doesn't mean nature actually allows them to exist. So far, no telescope, no detector, and no spacecraft has found direct evidence of a wormhole. The idea lives in equations and scientific imagination, waiting to be proven or disproven by future discoveries. The earliest version of wormholes was discovered when Einstein and Rosen studied black holes mathematically. They found that two black holes could be linked together in a way that creates a tunnel-like structure. This tunnel is called an Einstein-Rosen bridge. It connects two separate regions of space-time. But there's a problem. Their calculations also showed that this kind of wormhole would collapse almost instantly. It would open and shut so fast that even light couldn't travel through it. So technically, Einstein-Rosen bridges are non-traversable. Years later, in 1957, John Archibald Wheeler gave this concept its popular name, wormhole. He explained it with a simple image. Imagine a worm crawling through an apple. Instead of crawling all around the surface, the worm digs a tunnel through the apple and reaches the other side in a fraction of the time. That tunnel is like a wormhole in space. If natural wormholes collapse instantly, how could anyone actually travel through one? Scientists came up with a possibility: exotic matter. Exotic matter isn't like the ordinary matter that makes up stars, planets, and people. It has unusual properties. Most importantly, it can have negative energy density. Negative energy could create a repulsive effect strong enough to counteract gravity and keep a wormhole's tunnel open. This idea isn't pure fantasy. There are hints in quantum physics, like the Casimir effect, that negative energy can exist. If we could gather or produce enough of this exotic matter, we might be able to make a wormhole stable enough for travel, what physicists call a traversable wormhole. In theory, such a wormhole could allow a spaceship to jump light years in seconds, skipping the unimaginable distances that make space travel so difficult. This is where things get even crazier. A wormhole doesn't just connect places, it can also connect different times. This happens because time flows differently depending on gravity and speed, a phenomenon known as time dilation. If one end of a wormhole is moved at near light speed or kept near a massive object like a black hole, time at that end slows down compared to the other end. So if you step into the wormhole at one end, you might come out in the past or future relative to where you started. Imagine having two wormhole mouths, A and B. If B is taken on a fast journey near light speed and then brought back, less time would have passed for B than for A. Traveling through from A to B might feel instant, but it could land you in the future. Going the other way might send you to the past. But this raises serious paradoxes, like the famous grandfather paradox. And if you went back in time and changed something, would your future even exist? Most physicists think some natural law would prevent time travel from working in a dangerous or inconsistent way, but no one knows for sure. A lot of people confuse wormholes with black holes, but they're very different. A black hole is a region in space where gravity is so strong that nothing, not even light, can escape its pull. Once you cross its event horizon, there's no way back. A wormhole, on the other hand, would have two sides, an entrance and an exit. Instead of pulling everything into a deadly singularity, a stable wormhole could, in theory, act as a bridge to somewhere else. Some scientists think black holes might hide wormholes inside them, but if that's true, those wormholes are likely not stable or safe for travel. If you fell into a black hole, you'd be stretched and crushed long before reaching the other side. A traversable wormhole would need to be different, held open by exotic matter and free from crushing forces. If wormholes exist in our universe, where might we find them? One idea is that they're everywhere, but incredibly small, maybe smaller than an atom. These quantum wormholes could be forming and disappearing at the tiniest scales of space-time, far beyond what we can currently detect. Another idea is that some wormholes might be large and stable, hidden near massive cosmic structures like black holes, neutron stars, or in the distant voids between galaxies. Scientists are trying to detect them by looking for unusual gravitational effects. For example, a wormhole might bend light from distant stars in a way that looks different from a black hole's gravitational lensing. Detecting one would be one of the biggest discoveries in human history, but so far no solid evidence has been found. The idea of building a wormhole sounds like science fiction, but physicists have actually done the math. Theoretically, if we had enough exotic matter and energy, and if we understood space-time well enough, it might be possible to create or stabilize a wormhole. But here's the reality. The amount of energy required would be beyond anything humanity can currently produce. To keep a wormhole open wide enough for a human or spaceship, you'd need energy on the scale of a star, not something we can create with our current technology. But that doesn't mean it's impossible forever. Hundreds of years ago, flying to space sounded impossible too. One day, a far more advanced civilization, maybe even us in the distant future, might learn to manipulate space-time and build wormholes as easily as we build airplanes. Wormholes have inspired countless movies, TV shows, and books because they combine two things humans love: space travel and time travel. In Interstellar, a wormhole near Saturn allows astronauts to travel instantly to another galaxy, showing a realistic depiction based on real physics. In Stargate SG-1, wormholes act as fixed portals linking distant worlds. In superhero stories like Doctor Strange or Thor, wormhole-like portals are used to move between realms in seconds. These stories may exaggerate, but they're rooted in real science, and they keep our imagination alive. Wormholes aren't just a scientific theory anymore. They've become a symbol of the unknown, the possibility of exploring beyond our limits. So do wormholes actually exist? The truth is, we don't know. The math says they're possible, the physics allows them, but no one has ever found one. If they're real, they could change everything. How we explore space, how we understand time, and maybe even how we see reality itself. Imagine being able to travel to another star, another galaxy, or another era, not in centuries, but in seconds. That's the power wormholes promise. Somewhere in the vast darkness of the cosmos, a hidden doorway might be waiting to be discovered. And when humanity finally finds it, everything about our place in the universe will change forever. Thank you for watching. And if you enjoyed this journey into the mysteries of wormholes, don't forget to like, share, and subscribe. And tell me in the comments below, if you could step through a wormhole, where would you go?